Hi. So in today's lesson, we're going to be looking at what we call swords. Yeah, not sword, swords. All right. So we have swords. So what's the meaning of swords? Swords are irrational numbers, which are roots of rational numbers. Well, let me explain what irrational numbers are. So we have irrational numbers. So what are irrational numbers? So if you could write a number in p, if you could write a number in the form of p over q, such that p is not equal to 0, then such a number is actually a rational number. That's this. And if you can't write it, if it cannot be written in this form, then it is an irrational number. So that means if you can write a number in fraction, it's irrational. If you can't, it's not. So let's see examples, e.g., examples of rational numbers. Examples of rational numbers, we have 2, we have 3, because this is 2 over 1, 3 over 1, and we have 5 over 2, we have 22 over 7, and so on. We have 3 number 1 over 2, and sorry, not equal to, sorry, that's comma, then 3 over 2, and so on. So examples of a rational number, you can represent them as a fraction. Example, root 2 doesn't have a fraction. Okay, sorry, not root 2, pardon me. Pi, that's 3.142, and so on and so on. So approximately pi is actually approximately equal to 22 over 7, but that's not the real value of pi. That's just an approximation. So pi really has no exact value to write. You can write this in form of p over q. Then another example is this value here, e. I think e is about 2.14, something like that. So e is also an irrational number. So we have different examples of irrational number. We have, I said earlier that root 2 is also a irrational number, because if you type to your calculator, you can convert that to fraction. You have root 7, you can convert that to fraction, and so on and so forth. So let's look at what really a sword is. So swords are irrational numbers. Irrational numbers. Irrational. That means they can have the form of a fraction, which are roots. So they are actually square roots, or no, not square roots, roots of rational numbers. So example, you see this guy here. You see this guy here. Root 2. It's a root, then it has 2 inside the root. So 2 itself is a rational number, just like we have it here. It's a rational number, but it's a square root. So when you square root irrational numbers, so when you square root rational numbers, some rational numbers, you should get a sword. So if you have root 2, that's an irrational number, that's a sword. If you get root 3, that's a sword. Root 5, it's a sword. Root 22, square root of 22. Yeah, these are swords. Square root of 3.5. Square root of 3.5. These are swords. Then we'll move to the rules of swords. What are these rules? What are the rules that actually guide swords? So the first rule is that square root of a multiplied by b is equal to square root of a multiplied by square root of b. So you could separate the roots from each other. So you could actually divide the root from each other, and each values are actually independent, provided they are multiplying each other. So let's see an example. Let's say square root of of uh, of 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 8. This is square root of 8. So I could write square root of 8 as 4 multiplied by 2. So that basically gives me square root of 4, according to this first law, multiplied by square root of 2. Let's see another example. Square root of 15. So I could write square root of 15 as 5 multiplied by 3. And that's going to give me root 5 multiplied by root 3. So let me give you one more example. Square root of 14. So what do you think that would be? Think. Pause the video and think about that. All right. Assuming you have thought about that, so what you are going to be answering, that would be 7 multiplied by 2 is 14, and what I'm going to get basically 7 multiplied by 2, what I'm going to get basically is actually root 7 multiplied by root 2. So this is the first law or first rule of indices that you need to know. Then the second rule says that square root of a over b equals to square root of a over square root of b. So what they're saying basically is that you can separate this numerator from the denominator, giving each of them the roots. All right, so let's try to do that. So we see this and we say, okay, let's take an example. Let's say square root of 7 over 2, and so that has to be root 7 over root 2 based on this law. Let's another example, root 6 over 5. So that has to be 6 over root 5. And let's give you one example for you to guess the answer. Let's say root of 12 over 7. So what do you think that would be? Yeah, exactly. You have root 12 over root 7. So basically that's the second law. Then let's look at the third law. Square root of a plus square root of b is not equal to square root of a plus b. So don't make that mistake. It's a very, very important law. Don't make the mistake. So it's not the same. So let's say an example is, I'm going to ask a question. Is root 3 plus root 2 equal to root 6? Sorry, equal to root 5? No, it's not. It's not equal to root 5. Why? Because we can't say that that's equals to root 3 plus 2. No. You can't say that. So what about, can you say root 9 is equal to root 6 plus root 3? Can you think? The answer is no, you can't do that. Yeah, you can't do that. So that's the third law. That's what the third law basically says. So you can't add these operations together.